Previously on Project Rio here on youtube.com/Wi-Fi Sheep, we looked at the bare minimal setup to get a real self-build 8-bit colour Project Rio system up and running. Hopefully you are following along and you have your system ready for today's video, because in today's video we're going to add mass storage, something brand new to Project Rio. Hello, how are you doing? And welcome back to Project Rio here on youtube.com/Wi-Fi Sheep with me, Tom. Thank you once again for joining me for part 3 of our Project Rio series, where we are building a real 8-bit programmable basic computer system with colour, more RAM and advanced features. Basically an upgrade on our previous tiny basic computer series that we've been running in the previous few years. Today we're going to look at mass storage. This is something that we can do because we're running with the Arduino Mega. The Megas actually have more RAM, allowing us to run things like a filing system, allowing for SD card filing support. Basically, you can now save and edit files to micro SD card as opposed to having to save them just to the limited EEPROM space or needing a permanent serial connection to send data to a host computer such as a PC or Mac. If you want to build along, you will need to join the Project Rio Patreon tier. Details are in the description to this video, and from there you can download all the required files and source code in order to build. If you're not sure what this is all about, then go back to episode 1 of Project Rio, or go all the way back to episode 1 of our first series, Tiny Basic Computers, and follow along from there. Before we continue, Project Rio has been kindly supported by PCBWay.com, and as we're getting very near the end of the year, PCBWay have got their Christmas sale on. So do go and check that out. It's PCBWay.com. Details and links are in the description to this video. If you haven't done so already, do consider making yourself a free PCBWay account, especially if you need to use any kind of services such as PCBs, 3D printing, machine tooling, anything like that. There's loads of things PCBWay can do. It's extremely useful if you are doing a maker or build project, something like Tiny Basic Computers. So this is where we roughly left off last time, and I think the first thing we need to do is make sure that this rig, as is still working. So a USB keyboard goes into the Pi down here. HDMI also comes out the Pi. You can use HDMI or you can go through the yellow composite jack. So HDMI in there. And last of all, power, which we're going to use a standard 5-volt Raspberry Pi power supply. We're also going to go into the Raspberry Pi directly, because remember, we jump the power through and we power our Arduino from our Raspberry Pi board. Okay, that's the basic setup. Let's power up and see if that works. Yeah, okay, so we are still working, and this is where we left off. So, as I said in the introduction today, we're going to look at adding SD card filing support. Now, you'll notice here that when you boot up, it says SD card error. That is because the Tiny Basic Project Rio kernel that we're using is set up to look for an SD card. It can't find an SD card on the system, hence it reports back an error. Other than that, everything else looks to be working fine as we left it last time. So we'll power back down. Now, two things we're going to add today are SD filing support, as I just mentioned, and also sound. Sound has been missing for this project. We have it on the previous Tiny Basic system. We never included it here on Project Rio. The sound libraries are installed, they are running. It does output the signal for sound, but we haven't added a speaker or a buzzer. I have one of these little circuit board buzzer speaker things, which are relatively cheap, and there's 2 pins on the back. So we're going to add this to the circuit. Clear a bit of space here on the breadboard. I appreciate there's some cable in the way, but roughly here in the middle. So what we'll do is we're going to put the ground or minus pin. It's going to go onto the blue rail, and the positive pin is going to point this way into the board. So it connects something, if you can see, connect there, like that. Again, if I just move the wires, you should be able to see. Okay, and then we're going to use a single male-to-male jumper, and we're going to jump from the pin itself, which should be that one there. Remember, this entire row is now for sound, so that should be okay. And we're going to connect into pin D5. D5 on the Arduino, which is on this side over here, is for sound, and we'll push in D5. If I power back up, this should now work. I had misaligned it. Oh, there we go. Yes, so I've moved the pin along wrong, so I had misaligned it. You just heard the buzz work. That's now working fine. So you'll get that slightly grating start-up tone, which means we now have sound, and sound is enabled as standard on the Project Rio kernel. Okay, now the biggest thing I want to add today is SD card filing support. This is a big one and a huge improvement over the original Tiny Basic system. Because we're using the Mega 2560, we actually now have the RAM to run a basic kernel, basic interpreter, and also the libraries for sound and SD card filing support. So I've got one of these. These are one of the, I say official, one of the supported micro SD card modules for the Arduino platform. Therefore, they run on 5 volts. Now, awkwardly, this one has the pins with this sort of slightly bent pin configuration, which means that when we put it in the breadboard, it's going to stand up like that, which is a bit annoying, a little cumbersome. If you want and you feel competent, you can actually desolder the pins and put a standard pin header, so you can actually sit it like that if you wanted to. Because we're trying to minimize soldering as much as possible, I'm just going to mount mine like that. Now, as I mentioned, this version is the 5 volt version. So we're going to put that roughly, we'll put this side actually. So we've got the divide, we'll put it this side. Let's put it kind of like there. Okay. And I'm going to use 2 jumper wires. By the way, if you don't remember from last time, we are using a mixture of these large cable ribbon jumpers. We also have these mini pre-cut jumpers you can buy in these packs, and that's what I'm using. So we're using a mixture of both. So I have this grey wire, which I'm going to take 5 volts. Remember, we put 3 volts down here and 5 volts up here. So I'm going to pull 5 volts off my power rail from up there, and I'll just show you this quickly for the last time. You'll notice that on the silk screen of the SD card reader, it's got the pins labelled. And the bottom 2 here, VCC is 5 volts and ground is ground. And the others are the data pins, including the sync needed for the Arduino to read the SD cards. The second pin is VCC. So we'll just pop that in there. The first pin is ground. I have a little jumper. We'll go off the bottom ground rail. It doesn't matter which ground rail we use. They're both connected together anyway. So we'll just ground this on a second. Okay, so that's the power sorted. 5 volts in, ground out, no problem. The next 4 are the clock and data signals required for reading a micro or standard SD card on the Arduino platform. For this, I've got a 4-way ribbon, male to male, and I also have the pin out up for the Mega. Now, the pins we need are clustered here. These 2 here are ground, and then there's 4 next to them, and those are the 4 dedicated for reading and writing to SD card. Your colours will probably be different to mine, so you need to decide which is going to be which, and best try and start them in order if you can. So try not to twist the ends of the cables. There we go, so they're relatively straight. It just makes life a little bit easier. So we'll start from the other end, and the first one is CS. Yes, CS. So I'm going to put CS. Now, confusingly, on the Arduino pinout, it's not actually called CS. It's called SS. So CS will go to SS. And SS is on this side is the second pin. So ground and SS. So that's the first pin done. The next pin, and again it starts to get a little bit cluttered, the next pin is called SCK, and SCK will be grey in our case. SCK is right next to SS or SC, so we'll plug that one in like so. Remember, it's not the very bottom. Leave these two here because these are both grounds. It's not a disaster if you do plug into them, and again I just show you there, it's not a disaster if you plug into those, but be aware it doesn't work. Okay, it won't fry anything, but it just doesn't work, so be aware of that. Okay, so that's 2 pins done. Now for the next two. Now the next two are very similar to each other. So it's MOSI and MISO. Yeah, I know. So the next pin in my case will be purple, is going to be SI, MOSI. And if I just check my data sheet, MOSI is D51, so it's above SS, so it's above white. So purple is going above white. And the final one, by process of elimination, MISO is going to be blue. And so the final one in this cluster, they're all next to each other, they all sort of cluster together. There we go. Okay, so sound is in, and our SD card filing system, hopefully, fingers crossed, is in as well. Now, for SD cards, I've got a relatively small, reused actually, micro SD card, and this is formatted to the standard FAT32 format system, standard PC DOS FAT32. I'm going to put the card in first, and it's a click fit here on these type of connectors. So you have to make sure you push, click, and the SD card is installed. One final check just to make sure we have everything correct, and it looks fine to me. So let's power up now. I'm just going to cut you to, there we go. So let's power up. And hopefully, that's very, very loud, isn't it? There we go. So you can now see that the SD card error message has gone. Now I've got a series of files actually already installed. They're just simple text files. I've called them .bas for basic. You don't even have to do that. You just save your basic programs as ASCII plain text, and those files will be able to be read on a PC or Mac or even a Linux system with LeafPad, Notepad, WordPad, Notepad, whatever program you want. You can actually edit, upload and write your code off the system and then run it here on a Project Rio just by saving the text files to the SD card. So I'm going to load up a program which I know is on the system. So I'm going to go load demo.bas. Okay, and we can check if that's gone in the system by listing. It has. There we go. Also notice, if you look down on this listing from line 60 through to line 80, you can see how we can now chain programs. So this is simply a menu that allows us to chain to other basic programs, which means if you have a larger program that won't fit inside the 6K of RAM available on the current Project Rio system, you can actually chain out programs in and out as you need the data. So you could use the whole 6K for an intro splash screen, dump it, then have a 6K menu, dump it, then have a game screen, etc. So you don't have to have the whole program fit inside 6K if you don't want to. We've got more than enough space on a couple of gig SD card. We're writing very small files, so you do have the capability to expand out. So if I run the program, I'll show you what I mean. So let's go run. So here is the demo, and it says, what do you want to do? Let's go color test. So I simply say option 3. And what it does is it scraps the menu and it now loads the color test program. And here it is. And there is the color test showing the full 256 colors currently available on a Project Rio system if using Pi GFX module, which we are here on our Raspberry Pi for the terminal. Let's. What we can also do is we can also chain demo back in. So chain just runs the program. Instead of loading and running, you just chain it and it runs immediately. Standard basic protocol. Let's go to binary scroll demo number 2. And you've seen something very similar. I've shown this before. At the moment, time recording, these are the only demos we've actually got for the system. I do need to write some more stuff. We are working on more stuff for the system to do more programs. And you can find all these, by the way, on the Project Rio Patreon. Details are in the link to the description of this video. Alternatively, you can go to patreon.com/Wi-Fi sheep. So hopefully that all worked for you, and well done if it did, and you should now have quite a competent yet simple 8-bit computing system laid out on your desk. Next time we're going to look at how to tidy things up a bit, put it maybe on a board, and we'll also look at adding some basic joystick support. However, as it's now November at the time of recording, and we're shortly going to be heading into December and of course Christmas here on Wi-Fi Sheep, we're going to take a short break from Project Rio, so we will be back with this in the new year. If you haven't done so already, please do consider liking and subscribing to the channel. As always, thank you so much for your company, and I will see you real soon right here on the channel. Until next time, bye for now.